Hello, I'm Philip Stoughton. I'm here at Apex 2020 and I'm joined by Michael Ford from Aegis. Michael, first of all, I wanted to congratulate you. You picked up a couple of awards, but most notably, you've got the President's Award from IPC. Tell me what that was for.
It was really nice, when you go into IPC and you start to contribute to different things. Over the last few years, I've become part of several different committees. Traceability has been a key one. That was the one I started with. And then most recently with the Connected Factory Exchange. But then there's the IPC 2581, the digital product model. And what has actually happened is that we've seen a synergy between all of these different things working together. And so I've been kind of interested to see what we can do. Yeah. And I think it's that aspect of things that's been recognized, which is a little embarrassing for me because, there's a whole load of people behind these standards that have been working on them for many, many years, and I'm really happy to be a part of that. I'm very grateful for IPC to recognize that. And it's only just the start,
Yeah, and it's a big honor. But I think what's interesting is each time I speak to you about these committees, there's progress, and we're moving from one thing to another. We're, developing a standard for the digital twin, and then, we've gone through the CFX standard, and there'll be other stuff to follow on from it. And it really is that progression of standards that actually, or that progression of committees and interactions that I think is what makes it really valuable.
Yeah, it really is. And, some of the standards kind of go quite slow. With the traceability, I think we achieved the record in the time it took us to get to publication from when we started. For the digital twin, we want it to be even shorter than that. Yeah. Because, people have an expectation, and there are technologies available. And if you're not promoting them in a way that makes sense for the overall business, then it's almost like we're wasting a resource. Yeah. And the IPC has such tremendous resource here in the value of these standards. Just putting them together gets this much greater value. And that's the exciting thing about it for me. Seeing how all of the synergy works, seeing the lights come on in people's heads and saying, it's just a matter of making those connections.
Yeah, and I think it's hugely valuable. And like you say, I think it just shows the value of an organization like the IPC when it can bring so many stakeholders together from up and down the value chain as well. You see, OEMs, EMS companies, software companies, hardware companies, everybody comes together. Just to go off at a tangent, when we were chatting off camera, we were talking about some of the downtime challenges in the EMS industry, and you were likening changeover to Formula One pit stop. And unfortunately, it's generally not like that. It's more like an old-fashioned car service. Mm-hmm. Where do you see the room for improvement there, and how can things change?
Well, this is one area that came out of these IPC discussions because, I've been telling people that we see productivity levels typically 30% or even 10% in some cases. And people just seem to have accepted that as if it's a fact of life. And so, I suggested to some guys, look, go watch a Formula One race. And see what happens when the car comes into the pits, because you've got a team of people there who are understanding exactly what they need to do and when they need to do it. And you take like 3 seconds to process the car and it's back out on the track. Could we apply the same knowledge to manufacturing? When a changeover comes up, it's just like the car coming into the pits. We all know what we've got to do. There are several jobs that need to be done. Could we do them in parallel rather than doing them all in series? And so therefore you have a group of people, each with their responsibility, and they come in to do that job. The problem until now has been, how do people know when the car's going to come into the pits? Now in Formula One, you've got real-time communication with the car and systems. You've got the same thing now in manufacturing. So using the IIoT-based MES system, you can see exactly when these things are going to come up. You can plan to make sure that they don't come up simultaneously. You can understand the materials are there, ready and waiting to go. Your planning is such that you can schedule, for example, the reflow oven to be only heating up rather than cooling down. And so there are lots of things that you can do in terms of preparation, as well as having that real-time visibility of what's going to happen. And then you suddenly, send the team to this line, get the line changed over, 5 or 10 minutes later, you're running again.
Yeah, no, it's really interesting, and I like the analogy with Formula One generally, because it is all about the race, and is all about getting to the end first. One of the interesting things is that Formula One teams are a two-line factory, so they have two cars coming in, so you've got to time those. They use live telemetry. They actually are one of the pioneers of using digital twins, because they use digital twins to simulate the race and what if scenarios. So there's a lot to learn there. Do we have the data, the real-time data, and the capability to actually take those examples and apply them in the race that we're running?
We do, and it's a combination of the engineering data where we have the digital product model of what we're going to make. We understand the digital product model of the line, if you like, that the configuration it's going to be run. We understand where the people are and what their roles are, the materials coming in. So there are many different elements. So the IoT based MES platform is really responsible for the coordination of that, but it's really providing the visibility. Where the data comes from is quite a few disparate sources. For example, you have the information about the product that comes through IPC 2581, which is called DPMX now, and so we can understand how we've assigned products to lines and exactly what expectations and requirements are. All of the profiles, all of the programs and everything else produced on demand. So that's really, rapidly reacting to the need for change. And then we pick up the data from the line through all of the different machines. That comes through CFX, another IPC standard. And then we can also look at the results and the performance and the repair loops. That comes through the traceability, which is another IPC standard. The important thing about the standards is interoperability. Because for us, as an IoT-based MES platform, we offer value based on data integrity. And so the better the data is, the more trustworthy it is. And to be honest, we don't care where it comes from. You can use your favorite design system, you can use your favorite machine. It really doesn't matter anymore now that we're in this standards environment. And what that means for our customers is that they can be sure that whatever they need to do is going to happen when and where it's needed. So they can focus the resource, make sure that they can do this kind of Formula One approach.
Yeah, and it's a single source of truth that allows them to schedule those changeovers on multiple lines, because we're not talking about a race with 2 drivers in many factories. We're talking about a race with more than 10 drivers in, so we need to coordinate and schedule that. It's a broader ecosystem, but it's great that what I would refer to as those digital building blocks are now more and more in place, so someone can move much more quickly to that process.
Yeah, and I think people need to understand, because we've been talking about machine connection standards and all of these other kind of things, people have kind of lost track of what do we do with the data. It's not just data for data's sake. We need to look at some real practical examples of how the data benefits us. And Formula One is one example of that, if we use that approach. But there are so many more. And it's not new stuff. These kind of principles have been around for quite a long time. And it's almost like we're beginning to lose track of them because we kind of gave up, because the data wasn't there to support it. Well, that's all changed now. The data is there to support it. So let's revisit all of these things that produce real value. I've been to plants where I've seen this Formula One changeover happen. It's absolutely remarkable, and that site is the envy of the industry.
Yeah, and absolutely should be. And as you say, it's visiting all those principles that we've developed over decades of lean manufacturing, but revisiting them in a digital environment, which we should now have. Michael, always a pleasure to chat. Congratulations again on the awards. I think it's recognition of not just the ability to recognize the committees, but that ability to bring people together, which I think is hugely valuable. Thank you for your time.
Thank you.